Hi everybody, I'm Sébastien Deleuze. I'm a Spring Framework committer and I'm also responsible for the Kotlin support in the various Spring projects. And today we are going about how to run Spring Boot application as GraalVM native images. And we will use this opportunity to learn a little bit more what is GraalVM, what are native images. A few weeks ago, Jürgen Oeller, the Spring Framework lead, announced at Spring Web Platform that we are going to have a big focus on runtime efficiency. And part of this effort is a focus on GraalVM, both with the next-gen JIT compiler and native images, which is the main topic of today's talk. And let's talk about what is GraalVM. Because GraalVM is a project with a very wide scope. It's an R&D effort started at Oracle 7 years ago, I think, and it provides various pieces. It allows seamless interoperability between languages. It allows to run JVM code as native executable, a little bit like Go, and that's the main topic of the talk. But it also allows to provide an embedded high-performance JIT compiler that can run in databases, but also just on top of OpenJDK. It's important to have in mind there is 2 editions of GraalVM. The community edition is freely usable. That's an open source project. Source code and issue tracker are on GitHub. And the license is GPL with ClassPass exception. So this one, you can use it for free. But there is also GraalVM Enterprise Edition, which provides faster performance and smaller footprints, and various features to target enterprise, like enhanced security feature, managed capabilities for native codes, and it obviously requires a commercial license. So it's important to keep in mind that when you hear about GraalVM native, there is in fact 2 versions of GraalVM native with different characteristics. We are going now to see how to generate a native image. So to generate a native image, you first need to install the GraalVM distribution of Java. The easiest way for me as a developer is to use SDKman to install a -grl distribution available. That's the GraalVM distribution. So I install it with SDKman, and I need to enable the native image support because native image is still in preview mode, so you have to install it as an additional module. Then we are going to see a simple Hello World application. We first compile it with Java-C to a .class, because this is the first step. And after that, the native image tool will allow to convert this .class to a static executable. Here, notice I'm using -- static parameter to be able to generate a statically linked executable like with Go. And we are going to use that to run that on a Docker image which is smaller. So I can start my Hello World. Obviously, it starts very fast, almost instantly. And you can use that with a Docker file with this from scratch. So I don't use any base layer. I just use this small executable, and that will produce a very small Docker image, something around less than 4 megabytes. So given the fact that when we use the JDK without the modules, we have something around 100 megabytes, that's pretty interesting to be able to generate small images like that. And obviously, when we start our application via Docker, it allows us to start the application pretty fast, less than 1 second, even if we take in account the startup time of the container. So this is the first thing to show you what is GraalVM native and how do you compile Java code with this tool. But GraalVM native is not a free lunch, and it has some limitation. And today I'm really here to share about why I'm excited about GraalVM native, and also to talk, to be very transparent about the limitations and the drawback when you use it. So in terms of limitation, a lot of Java features are supported, but there are some limitations. GNI, unsafe memory access, and references are mostly supported. Some features are not supported and will never be supported. So CGLib proxies, dynamic class loading, unloading, invoke dynamic finalizer, security manager, and JVM TI are not supported. There is other features that are supported, but with configuration, and we are going to see later what with configuration means. Reflection is supported, and GraalVM native has a pretty good support for reflection. You need to configure it explicitly. Because GraalVM native remove all the unused code in a very aggressive way to keep the image size smaller. So when you use reflection, the compiler is not able to identify that you are using this part of the code. So you need to do that via configuration. Proxies are supported, but only dynamic proxies on top of interfaces. And resource access need to be configured because it's the same. Image size need to be small. Another interesting point is class initialization. With GraalVM native, you have build time. So when I say build time, it's native image build time, initialization, or runtime. By default, GraalVM native initialize your class at runtime, like on OpenJDK, but you can, with some explicit configuration, initialize your class at build time, and that could provide some optimizations. But it needs to be supported by your framework, basically. And it can get tricky when a group of types pull in other types unexpectedly. So another quick demo. So we have this hello world where we add a static block with systemout.println with static initialization. I still compile it with javac, and by default, like I said, if I compile it with native image without any additional options, it will be like with OpenJDK. So nothing happens at build time, and when I run this application, I see the static initialization printed at runtime. Now, if I add a parameter to specify that I would like the static initialization happen at image build time, you will see a pretty different behavior. So we compile it, and here, static initialization is displayed during the build time. And when I just run hello world, I will just have the code that is run on the main method. So static initialization is used for a wide range of purposes in Java libraries, and GraalVM has no way to guess if it should run it at runtime or at build time. So by default, everything is at runtime, and its various libraries and frameworks should configure it at build time if needed for optimizations. So how can we configure GraalVM native? The first way is to use static configuration with JSON files. So you specify the class name, and you will specify the constructors, the method, and the field that you want to keep. Because if you don't specify that, and if you are using that via reflection, for example, the code will just be not available at runtime. Okay? So you have to craft some configuration. You can do that by hand, or it can be generated by a native image agent. The native image agent will basically run on top of the regular Java. You run your code, and it will register any reflection call, any resource access, and it will generate automatically a configuration file that you can then use to compile your application with native image. It's possible then to use this static configuration on command line, or you can put the resulting files in well-known location in the class path. So if you are using libraries that provide GraalVM native support, it's possible to just bundle that into the jars. And both configuration, command line and on the class path could be used together and will be merged. There is a more powerful way to configure application and framework to use GraalVM native. It's via feature. So a feature is basically a library that is using graal-hotspot-library. And you can create a class that will implement the GraalVM feature interface. It will be possible for this class to be called back to participate in the image building processes. And it will make it possible to register dynamically at build time, reflection, resources, proxies, initialization ending. And you can use at automatic feature to ensure it is picked up from the class path automatically. If that's not enough, there is a more powerful but more dangerous way to make your library or application working with GraalVM native. It's with substitutions. Substitutions just replace a method by another. And that's super powerful. We usually use that as a workaround for pending bugs on GraalVM native site. But we try to really avoid this kind of mechanism because basically you are running untested code. If your library is updated, you will not get the improvements, so that's not sustainable at all. So it's really something we try to avoid. Now that we have seen the low-level stuff, why GraalVM native is exciting? The first obvious point is that it allows to start application almost instantly. We have support for Spring Boot, Spring MVC running with Tomcat. We have not done yet any optimization on our side or in the GraalVM side. And even with that, we are able to start almost instantly Spring MVC. And that's super interesting because that allows to build scale to zero applications. I mean, everybody try to lower the cost of the cloud hosting. And if you are Netflix and you are building application with high throughput, you probably don't care about GraalVM native. But if you are in a middle-sized company building some back office that is used 10% of the time, if you have the possibility to pay $0 or euros when you don't run the application 90% of the time, it saves you a lot of money. And scale to zero application with instant startup allow to do that. I think there is also another use case. It's for high availability. With regular application, you will usually run 2 instances of the same application. Here, with scale to zero, you can run just one. And if one don't respond, you will start a new one instantly. Another point is the CPU and memory profiles. At the left, you have OpenJDK JIT with low XMX. Running Spring MVC and Spring Boot, you see the CPU spikes at the beginning because the JIT is optimizing the code at the beginning for the most used code path. And after that, the CPU is more constant. And you see the memory usage. So this memory usage is not just the heap, it's all the memory, including the native one. Because with JIT, basically, even if you have a very, very small Java application, you will need almost 200 megabytes just to run the JIT correctly with high performance. With GraalVM native, that's different. The memory consumption is lower. Here we have almost twice lower memory usage, and we intend to improve that even more because, like I said, no optimization has been made yet. So we could make this difference even bigger. But be careful, that's only true for small application. So if you are running big application, you probably don't care about GraalVM native. If you are running a lot of small microservices, that's where the difference of memory is very significant. You also see that the CPU usage is pretty constant because everything is done at native image build time. So when you run your application, peak performance is available at the beginning, mostly, and you have a constant and predictive CPU usage. So these are the use cases where GraalVM native is interesting. The most important point is, in my opinion, less memory consumption for microservices. I mean, if you are building a system, you have 20 microservices, you run each of them in containers or in the cloud, it consumes at least, I would say, 500 megabytes for each. If you can divide by 2 or by 3 the amount of memory used in terms of cloud cost of the hosting, it's super interesting. For container friendliness, I think it's more balanced. For sure, GraalVM native allows easier configuration for the memory because fine-tuning the memory used by the OpenJDK JIT with containers is super tricky. It's so tricky that we have created a dedicated project to do that. So if you are using Spring Boot or any Java workloads on containers, I advise you to go to this Java Build Pack memory calculator, which is just a simple Go program. You provide the total memory you want available for your application, parameters like the thread count, etc. And it will generate all the Java parameters to fine-tune the memory according to runtime on container. So feel free to have a look. That's a very small Go program that carry a lot of our experience in terms of running Spring Boot application and containers. For container image size, so yeah, it's super sexy to be able to create Docker images from scratch. The images are pretty small, But I mean, with the JIT is better on uncatched layer, and that's probably what you care the most because GraalVM generates a single executable with the JDK and the application. So basically, you have one layer with everything, and it takes a pretty long time to generate. While with the JIT, if you really follow the guidelines, and I will show you the guidelines just after that, it's probably more interesting in terms of size of the uncatched layer. And image size could be reasonable, not small, but reasonable if you are using a slim-based image. In Spring Boot 2.2.1 that will be released today, we have added a new chapter in the reference documentation, which is called Deploying to Containers, that contain all the guidelines created by DevSire to run efficiently a Spring Boot application with OpenJDK JIT on a container. So feel free to have a look. I see a lot of people still deploying on containers with FatJar. So we explain here how you can have much faster startup and how you can really split your Spring Boot application into 3 different layers to have more efficient deployment with containers. So really, yes, GraalVM native is super exciting. But at the same time, beware of truncated point of views. There is multiple criteria to evaluate. And maybe my criteria are not yours. So you need to adapt that to your use case. So GraalVM native is super great for startup time, memory consumption, container friendliness. But there is also other criteria like latency, peak throughput, packaging time, monitoring, maturity, consistency between dev and prod, because for real application, it takes quite a long time to generate native images. So don't expect using that on development. On development, you will still use OpenJDK JIT, and that's only for runtime on your platform more efficiently that you will use native images. And the other point is that you need to differentiate GraalVM Native Community Edition from the Enterprise Edition because they have different characteristics. For example, Enterprise Edition provides peak throughput, higher peak throughput. The other dimension you need to take in account is time because GraalVM Native is a pretty young project, and the GraalVM team does a pretty good job to make this platform even better. So I have created this diagram based on the information I have. Maybe some points should be verified next year, but the idea is that GraalVM Native Enterprise Edition will improve significantly the latency and the peak throughput, and basically GraalVM Community Edition will stay the same. So really update also your criteria and your evaluation with the evolution of the GraalVM native platform. I would like now to focus a little bit on comparing GraalVM native versus the JIT, because like I said, you can use GraalVM native GraalVM compiler on top of OpenJDK. So we have done some benchmarks. That's a simple Hello World HTTP endpoint. We are using WRK2, and we are using log scale because there is a high tail latency. A warning that just to show you the current status, no optimization has been done yet because we are just starting working on that with the GraalVM team, okay? So we expect to improve that significantly, both via improvement on Spring side and GraalVM side, but we really would like to show you where we are today. So if we compare with Spring MVC and Tomcat, GraalVM Native versus the JIT, with GraalVM Native Enterprise Edition, we have a similar latency for the 81st percentile, and for the 20 last, the JIT is much better. GraalVM Native Community Edition lags behind, but it enables scale to zero application and is suitable for memory constraint environments. So again, it's not magical. It depends on your use case to basically decide if that's interesting for you or not. For Webflux, we see more difference, but we are working again with GraalVM team to fix that, and we expect the difference to be much lower until we fix the remaining bugs. It's important to know that GraalVM Native uses a non-parallel GC for now, both on Community and Enterprise Edition. And next year, a new parallel GC closer to the JVM1 should be available. So again, this platform will evolve, and we will benchmark again with the new garbage collector. But GraalVM embeddable compiler is also usable on top of OpenJDK JIT instead of C2. So this is the tiered compilation available since Java 7, I think. Your code is going through a pipeline through the interpreter, C1, which is the client JIT compiler, and C2, which is the server JIT compiler. And GraalVM compiler can be used instead of C2. So here we are really on a regular OpenJDK runtime where we just replace C2 by the GraalVM JIT compiler, and it requires no specific support. I mean, you can run nowadays Spring application with this new optimized compiler. And what we see in terms of performance is that we have 5% lower median latency, again, without any specific optimization. I think it will get better with the GraalVM EE-JIT compiler instead of C2. And with our reactive stack on top of Spring Web Flux, we have 10% lower latency. So pretty interesting use case. And again, it's usable right now, no need for special support. Now we are going to focus on the real topic of this talk, which is how you can run Spring Boot application as native images. In terms of timeline, last year I was showing here at Devoxx a special kind of Spring application. It was using functional bin registration, not annotations, and it was running on as a GraalVM native image, but that was a very specific kind of Spring application. So our goal this year was to make it possible to run regular Spring Boot application configured with annotation on top of GraalVM native. So for that, we have created a new project which is called Spring Graal Native, and we have made some significant modification in Spring Framework and Spring Boot to do not require any more CGLib proxies. And that's CGLib proxy-less usage of Spring Boot is still already available in Spring Boot 2.2. So this Spring Graal native project is available in the Spring Project Experimental Organization, like its name means it's experimental. It provides a Graal automatic feature that allows to dynamically analyze your application, the part of the Spring Framework, and the various Spring projects that it is using, configure everything at GraalVM native level. For now, it includes some JSON static configuration, but our goal is to go to zero static configuration. And it provides various sample applications that you can use yourself to try Spring Boot application on top of GraalVM native. It's important to understand that every Spring project, Spring Boot, Spring Security, Spring Data, Spring Cloud, is using abstraction from the framework. So we are focusing our work on the framework because if we make the Spring Framework abstraction GraalVM native aware, basically we can run all the other Spring projects on top of that, including your Spring Boot applications. So that's what we are doing with the Spring Graal native feature submodule. It's basically an automatic feature that implements a feature provided by the GraalVM library, and it allows us to dynamically, at build time, configure reflection, proxies, resources, and the initialization behavior. In terms of feature handling, typical applications scan a very small subset of the class path, and it's pretty fast, but not ideal for for GraalVM native. So we are leveraging a module which is already existing, which is Spring Context Indexer. Spring Context Indexer is a dependency that is already available. You can use that in your application, and it will generate at compile time a Spring.components project file that will contain all the bins. And when you run your application with this Spring.components file, it won't do any class path scanning. So we are leveraging that. It's already existing, so we have improved that. And we are leveraging that to avoid class path scanning when running on GraalVM native. The second point is that Spring generates classes at runtime, but JDK proxies are fine. You just need to register them. So that's what we do with the feature. CGLib proxies are no longer necessary because Spring Boot 2.2 has removed all usage of CGLib proxies for configuration, thanks to this proxy bin method equal false parameter. So we are safe, and it's compatible with GraalVM native. Spring uses reflection, and that's okay because GraalVM reflection is pretty great. So the feature knows what kind of annotation or framework usage leads to reflection needed at runtime. And the feature chases down annotations like at import and configure everything at GraalVM native level to make sure your Spring application is running fine. It also does the same for the resources. And finally, Spring Boot has auto-configuration enabled by the presence of class path, of entries on the class path. But at image build time, the complete class path is known. We are with close world assumptions. And so the feature just analyzes the configuration. We take this opportunity to remove any configuration class that is not used. So we are just shipping at runtime the configuration class that are effectively used to provide more optimizations. So I'm going to show you some quick examples. So basically, Spring Webflux with Netty runs fine on GraalVM native. It works with both Java and Kotlin. Coroutine does not work yet, but we hope the related bug will be fixed because that's pretty important for us. It's important to notice that Netty provides its own GraalVM native configuration, and we really would like this pattern to be seen in other libraries. So it's very important for each libraries to support GraalVM native, and that's pretty nice to see Netty supporting it. There is Spring MVC with Tomcat, which is supported, and Tomcat also includes its own configuration for GraalVM native. And we have also Pet Clinic. So for now, it is the Webflux Netty flavor, but we didn't at the time to port the regular Spring MVC Tomcat 1, but it will run in a short amount of time. And I would like to highlight here that just by upgrading to Spring Boot 2.2 in the regular OpenJDK JIT, you will have significant gain in terms of startup time and memory consumption. So the first thing I think is to update your application. So we are going to see a little bit that. So if I have a look to Spring MVC Tomcats and I run it, I have already compiled it to not lose too much time. So you will see that this is a Spring MVC application, a basic one. Okay, just a simple endpoint, but you see that it starts pretty fast. And I can request it, and that's okay. I can show you the same for Webflux. So this is Webflux with Netty runtime, and in terms of startup, we are pretty fast. And if I test it, okay, it works. And we have even to show you a more complex example. Obviously, we have this Pet Clinic example. Okay. So you see it's starting super fast. That's a quite complex application. And so let me just show you in the browser. So this is a Pet Clinic application that is working with GPA and everything. So yeah. It's not yet perfect, but we are very far of getting this kind of application running fine, even if there is some remaining optimization. So in terms of roadmap, like I said, last year we achieved to start the first Spring application with GraalVM native. This year it was more some exploratory work to check that we can run regular Spring Boot application on top of GraalVM native, and that works pretty fine. We have created the Spring Graal native project, and next year our goal is to go the next step, and Spring Framework 5.3 will provide out-of-the-box setup for GraalVM native. Okay, so we are going to work pretty seriously on that. To show you how much we work seriously on that, the team actively involved in that work will be composed by Jürgen Oeller, the Spring Framework lead, which will work a lot on that. Andy Clément has done most of the work on the Spring Graal native project, and Andy Clément is just amazing. I mean, it's AspectG lead. He has created Spring Expression Language, and he has done an amazing job. Dave Syer, founder of Spring Boot, Spring Cloud, Spring Batch, and he has done an extensive work about performances of Spring application, and is working a lot on that. Sam Brennan will help on the unit test side, because the unit testing and integration testing with GraalVM Native is an important story, and I will talk more about that. And Brian Clausel will provide more resources from the Spring Boot team. Our focus currently is on testing out-of-the-box setup and optimizing memory consumption. The testing part is very important because until now, basically, we have run some basic Spring Boot application and we have tried to make it work on GraalVM Native in an integrated way. The work we are starting here for Spring Framework 5.3 is basically running the whole Spring Framework test suite. Okay, we have thousands and thousands of unit tests, and we want to run them as GraalVM Native images, see what is green, what is red, and fix things gradually, but to really identify what part of the framework are supported. Some will never be supported. For example, any test implying CGLib proxies will obviously never work. But for the rest, it's just a matter of reflection, resources, proxy configuration, and we want to really have regression testing. And we are considering GraalVM Native as a platform like we run our test suite on the various flavor of OpenJDK. So we already have some unit tests working on GraalVM Native thanks to JUnit 5, and we are going to increase that work to drive our effort to improve the support. Expect the design to evolve significantly. So if you have a look to Spring Graal Native software design today, it will move a lot. Okay. We may update some part of Spring Framework core if needed to optimize things and support GraalVM Native in the best way we can. Not decided yet if we will graduate Spring Graal Native outside of the experimental organization or if we will directly integrate a GraalVM Native support deep in Spring Framework. We will see later. My gut feeling is that the work on GraalVM Native could trigger improvements useful on OpenJDK as well. So I tend to think that this effort of supporting GraalVM Native could enable some optimization and improvement on the regular OpenJDK side. The third-party libraries part is very important because GraalVM Native support needs to be sustainable and maintainable. That's why we do not want to maintain a fragile patches for the whole JVM ecosystem. Spring Boot is the integration point of the whole JVM ecosystem, and we would like to use that to collaborate with the open source communities, with the various libraries and frameworks that we integrate, to work with them and collaborate with the GraalVM team to basically provide GraalVM Native project directly at each library level. Because who knows the best if some class should be initialized at build time or at runtime than the library maintainer. We really would like this GraalVM Native support be part of each library when it's possible. So we are ready to take an active role in that, helping for guidelines, even providing initial PR for the related libraries, but we really would like this support be done directly at the library level. And in a nutshell, Spring should be a good GraalVM Native citizen for its own code base and should support GraalVM Native compatible libraries. GraalVM Native main challenge, in my opinion, is to build a sustainable ecosystem based on the existing JVM1, and we would like to work together with the community about that. The collaboration between Spring and GraalVM team has started, and I would like to thank Thomas and all the GraalVM team because it was pretty interesting to collaborate with them. Until now, we have raised dozens of issues on GraalVM side because GraalVM Native was not supporting all the Java features we needed in Spring, and they have been super responsive, and we really thank them for that. And I think with the development of Spring Framework 5.3 starting in the upcoming weeks, we are going to increase very significantly our collaboration, and I think it could be win-win for Spring and for GraalVM. Last hint, even if I can't talk too much about that, but there will be connection with Spring Boot upcoming Kubernetes story. We see that this GraalVM native has some link with better container support, and it provides different characteristics for interesting, especially for microservices. So there will be some interesting links between this kind of topics. I would like to thank you. You can find the Spring GraalVM, the Spring Graal native project on GitHub. Feel free to have a look, not necessarily to say that something is not working, because we are working actively on that. But if you have some ideas in terms of design improvement, or if you want to just chat with us, don't hesitate to contact us about that. And thank you for your attention.